This is the part third video of solid principles. So if you haven't watched my previous videos, then please watch that video. So let's understand what is Liskov substitution principle in C#. So the definition is very simple. Subtype must be substitutable for their base types without affecting program correctness. It means the subclasses must be substitutable for their base classes. Or in simple term, we can say subclasses should not break the behavior expected from their base classes. So let's understand with the help of example. Okay, so guys, as you know that here I have created this class payment processor. So this payment processor class is doing the payment functionality, process the payment. Okay, in future I'm having two types of payment processor for credit card and cash payment. So in case of credit card payment, we also need credit card number. So in that case, how we will get this credit card number? It will break the functionality because this function is required only amount, and here we also need credit card number. So in that case, this class, or we can say this class, is breaking our functionality. But in case of this cash payment, in this case it is breaking fine. As per our definition of this Liskov substitution principle, subtype must be substitutable for their base types. So to achieve this, what we can do, let me comment this because I already created the code. So let me comment this as it is not required. I will rewrite this code to achieve the Liskov substitution principle. So what I will do here, as I can see here, I have created this interface. Payment processor, I make it is a interface. In interface, I am having a abstract method called process payment. So in this process payment, I need to ask one parameter is called amount. The amount value I need to pass. So in case of credit card payment, what I am doing, I am implementing this interface. Process payment method is implemented within this class. Okay, but here through the constructor, I am assigning the value of this credit card. Okay, through this constructor I am assigning the value of this credit card. Now in this case it will not throw any kind of exception, so our functionality will work as expected. But in case of cash payment, it will again implementing the payment processor. In the payment processor, it is asking amount field, so I will pass the amount and it will work as expected. So in that case our functionality will not break. So let's understand here how I will call this method. So suppose I have created another class called program2. Here I am creating the instance of this payment processor through this cash payment. So in case of cash payment, I don't need any kind of credit card number. So in that case, I am just passing the value, or we can say amount. Okay, so this method is required only one parameter called amount. So I am passing the amount. But in case of credit card payment, here through the constructor I am passing the credit card number. Here you can see our functionality will work as expected. So in such a way we can implement the functionality so that the child class will not break the functionality of the base class. This is how we can implement this Liskov substitution principle. So here I already discussed about this code. So what is the problem in this code? It is violating the LSP principle. Liskov substitution principle, it is violating because here this method is breaking the functionality of the base type. So guys, in this code we are having some problem. So what is the problem we are having? The credit card payment class adds a restriction, card number is required, so which violates the LSP. Why it is violating the LSP principle? Because it forces client code to check for a credit card number before using the class. So we must have to provide the credit card number. That's why it is breaking the functionality. If we replace payment processor with credit card payment, it may throw an exception, breaking the expected behavior. So that is the problem in that code. So to overcome this problem, we have implemented this functionality like this. So first we have created one interface, and then we have created two separate class. With the help of this interface, we are implementing this interface for both the classes, and through the constructor we are passing the credit card number. But in case of cash payment, so we just need to pass amount as we can see here. So in such way we can achieve the Liskov Substitution Principle. Okay, so what are the benefits of following Liskov Substitution Principle? Now, any I-payment processor can be used interchangeably without breaking the problem. Suppose in future new payment type is introduced. So in that case, what I just need to do, I just need to create a class like that. Suppose bank payment will be introduced. So in that case, I will create a new class like this, and for that I just need bank account number. So I just ask through the constructor, and then I can provide the bank account number and then amount. Like this, we have implemented this way. The same way we can implement that feature again. So base type behavior will not change. Okay, so our functionality will remain as it is, means our functionality will not break. Client code does not need to check for conditions before using the credit card payment. So as you can see in our example, as I discussed here in here, credit card payment. So client code does not need to check for conditions before using the credit card payment. So in case of future, if new payment type is introduced, we can easily implement like this. Okay, so more maintainable code and scalable code as new payment method can be added easily. So by following Liskov substitution principle, we can achieve these benefits. Thank you guys for watching this video. I hope you enjoyed this video. If you have any doubt, you can ask me through comment. Thank you guys.